you haven't met, I'm Kim. I'm going to give you guys a quick intro to Crystal. Is anyone here using it? Has anyone here heard of it?
This is the reporting thing?
No.
Fast!
I saw Alexa.
Yeah.
No, it's better. So for the rest of you, you might be wondering what this is. It's a language. It might look pretty familiar. You guys all pretty much know what that does, I hope. It's a language which is heavily inspired by Ruby, but there's a couple of nice things. So it's compiled, which is gets used a fair few sort of speed and performance niceties. Uses LLVM, which just makes it super fast. There's a static type system with inference all the way throughout. So it gets rid of all those things of we have a nil, which maybe shouldn't be. Where you're passing things around which are different to what you expect them to be. You don't get issues in production. You get all that when you compile, resolve them before you put something live. You've got nil checks all throughout the code. So again, you're not trying to send a message to an object which doesn't exist. There's still metaprogramming. So although you don't get the nice dynamic metaprogramming that you get from Ruby, you have it's not really a templating system. It's like a self-expansion system within the compiler. So you can write metacode, which then compiles out to nice optimized static code. And it's a modern language, so you have this beautiful, nice modern library. So internal, really performant HTTP server, parsers for all your common data types like JSON, XML, etc. Lots of just nice things out of the box. So if we were to have a look at something.
Sorry, just as a quick, why would I use it versus any other language that I might already know?
Let me show you. So here's a simple bit of Ruby, just compute a sequence of Fibonacci numbers. So if we were to run this in Ruby, so this is a relatively fast machine. There's a fair bit of number crunching that has to happen there. Hopefully this should finish. There we go. So sort of 10 seconds or so. That's use the Ruby's performance. If I was to pipe that exact same code, so remember I said Crystal's super inspired by Ruby syntax. It's not the same. Not all Ruby code is Crystal code. Not all Crystal code is Ruby, but there's a lot of similarity there. So if I pipe that through our Crystal compiler, that'll build it. We now have a nice binary of that. So exact same code. Slight difference there. So our 10 seconds versus 0.55 a second. There's a lot of nice things that happen in the background there. Bit more of a complex example. I mean, most of you, I'm guessing, probably work somewhere in the web world. This is all built in standard libraries, so you can spin up a web server super quick. This is then super performant. You don't need to use the basic things. You have all the nice libraries on top of it. If you're using, say, might be used to a language which looks sort of similar to this, or a tool that looks similar to this. So Sinatra, if you're using that, there's similar implementation in Crystal. Gives you similar sort of syntax, but with a couple of differences. It doesn't look the best on here, but for reference, our response time is 395 microseconds. Like, this is crazy in comparison. As I said, we get things like nice nil checking. So if we do something like this and it's, might not actually have a value when we go to run it, we get that issue at compile time. So you get all the nice things of a static, type checked, compiled language with the beautiful syntax of Ruby. So it's just focusing on that programmer enjoyment with all the nice things of a bit more of a modern language. There's a built-in dependency management system called shards. So just YAML descriptions. It's decentralized, so there's no central repository. There's no people putting packages up on npm and having to conflict about names. It's just stick packages wherever you like. There's a couple of plugins to make the syntax a bit nicer, places like GitHub. But everything out of the box. You build a project, you set up a shard with it. It can be used as a dependency in other projects. Couple of caveats. There's no compile for Windows XE yet. They're working on it. But you do have compile for native Mac, compile for native Linux, and optimization for those platforms. And it's still not V1. So there are people using this in production. I think it's the big QA, like not Treehouse, like Green something. So Rainforest, there you go. They're using this. There's a couple of other places as well. Like we're starting to play around with it a bit. We're going to be porting across a lot of our platform to it just because it's amazing. But dig in, have a play. I find the easiest way to actually play is just to actually get in and try things. So there is play.crystallang.org. You don't even need to install anything. Chuck in some Ruby code, see where it evaluates, see where it falls down. I've got a really nice guide to get you started. There's a couple of nice posts around as to simple syntax differences. You can find all the info at crystallang.org. It'll have setups for pretty much every system out there. You can run it on Windows under the bash on Ubuntu on Windows. That works, but just not as a native XE. You can find me, Simple.Industries, that's links to my Twitter, my GitHub. I've got a couple of Christo repos there. And ACO Projects, the company I'm working for, so we're looking at porting some of our stuff over there now. But as I said, it's still, it's been around. I think it was birthed about 2012, 2013, but there's a fair bit of development happening on it at the moment. It's all open source, it's bootstrapped, so the compiler is written in Crystal. If you learn Crystal, you can contribute back to language, contribute to the compiler. All the discussions are in the open on GitHub. Super, super nice. Definitely encourage you guys to have a play. Yep.
So what's the standard library like, and how's the support for databases?
Yeah. So I'm trying to think of what connectors are there out of the box. You've got all the web stuff. The web server's got built-in WebSockets, as well as just serving straight HTTP requests. There's also language classes. There's a OBDC connector. I'm trying to think of what else is in there. There's a pretty. They're trying to, before they get to V1, pretty much match what's in Ruby standard library, but with a little more of a modern twist. So they've gone, if there's like legacy stuff that nobody uses anymore, we're not going to bring that in. We're just going to build what we need to build the compiler itself. So they bootstrapped the compiler in Ruby initially, then ported it to Crystal. As part of that, they said, oh, actually, we need to implement this, which depends on this and this and this. So they sort of built out this tree from there.
When you compile that binary, what does that look like compared to, say, like a Golang binary?
It's a native binary. That's everything you want. You can take that single file, it's portable, it's all there. So it uses, if you guys haven't used LLVM or played with it or heard of it, being Ruby, if that's your main thing, it might be a bit outside of your context, but it's amazing. It's a intermediate language, so other languages can target that in their build process, and then there's a whole bunch of optimizations on there. So there's a few different languages which use that. They've got pretty similar performance, and I think Haskell uses it as well. It's crazy. Yeah.
Yeah. So what's the biggest difference between this and say Elixir? Just the syntax is supposed to be faster, but
it's they're trying to focus on going. There's some projects where you might spin it up in Ruby. This is just really beautiful to build things in. But then you get to the point where we need some better performance. So that's when you start looking around other languages. So rather than starting in one language, which you might hit performance barriers on, start in a language which takes all the nice things of that language, but which doesn't have performance issues. So you still have all the developer enjoyment. You still have all the niceties of working in there, but you still have amazing performance. Also, very little learning curve. So if you're writing Ruby, you can get going with this in less than a day.
So what about porting stuff? Like, how does that look from?
Yeah. So some stuff will come across straight, but not all Ruby is Crystal. Not all Crystal is Ruby. So there's some changes in the language. Like one of their focuses on not having masses of aliases for different common things. So just going, yep, cool. We're just going to call things what they are, and not have this different conflicting terminology. So if you've got, if you're using the alias which they decided not to keep, you're going to have to change a few things. Some different things, like you still have got blocks and procs and all that sort of nice thing, but there will be little things which you do need to work on changing. And there's things you can optimize and do in nicer ways.
Is there any place where the same syntax actually has a different meaning, so it's going to break if you just chop and compile? This is what I have to do to do the port.
In In terms of if you just take a bunch of Ruby code and try to compile it, it'll tell you if there's any ambiguity. So most of the ambiguity will be around, say for example, types. You might pick up errors in there which you hadn't seen in a production system, but just had been there, but they've just been hidden. So you've got your type system, you can build union types of things, so if you're assigning things different points, they have multiple types associated with that variable, so you can still keep quite a dynamic programming style, but you need to handle all those edge cases. So it really protects you.
What problem were you facing with Ruby that led you down this path?
Speed would be the main one.
Like what? So I get that, but what was the thing that you need to increase the speed on?
So our product is a platform for sort of, lack of a better expression, IoT devices, so a lot of building automation, so lots and lots of parallel communication, lots of little devices, and trying to scale that to have one or two servers handling multiple buildings or multiple university campuses and every little device in there. So we're hitting some bottlenecks in terms of once you start really scaling out. More of a preemptive measure for us. It's just a super nice language.
How's the threading support?
So threading at the moment, there's concurrency, but there's no parallelism. We're working on the parallelism. Concurrency is all done through fibers. So it's preemptive multitasking rather than, preemptive rather than whatever the other one is. But really just, nice performance on that front. And the parallelism should be there for V1.
Thank you very much.
Thanks, guys.